Hello, everyone. Welcome to our webinar. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we are looking at quantitative research questions, how to frame them, how to develop them, specifically based on different research designs. So we'll look at a particular research design and look at the specific questions you could draft for that specific design. We'll send everyone a copy of the webinar in addition to the PowerPoint. If you have any questions, you can type them into the chat box or the Q&A box. And at the end of the webinar, we will do a Q&A session. All right, so let's dive in. First, I'll give an overview of the services that we provide at our company. Then we'll look at construction research questions and hypotheses. We'll conclude with a summary and a Q&A session. All right, on this slide, you can see all the different parts of the dissertation journey that we assist with. Our company has methodologists, both quantitative and qualitative, and we also have literature review specialists. So we can help you from the very beginning at topic development. If you need help picking a topic, framing research questions, your purpose statement, problem statement, finding literature and the gap in the literature. And then we go into all the individual chapters. So if you need assistance with a particular section, we can help you there. We help with IRB forms, data entry templates. We can upload a survey for you on SurveyMonkey or Qualtrics. And then we can even assist with the results chapter. If you just send us your data and your methodology, we can run the analyses for you in SPSS or our company software Intellectus. And then wrapping up the dissertation, we also assist with the discussion, PowerPoints for both proposal and final defenses, and we can condense your dissertation into a journal submission. So let us know if you have any questions about the services. You can give us a call for a free consultation at 727-442-4290, or you can use the hyperlinks that Sierra put in the chat. On this slide, you can view the past webinar recordings that we've done at the webinar archive, or you can register for future webinars at the top link here. All right, so for today's topic, we're looking at research questions, specifically quantitative questions. But before you get to that step, you need to lay the foundation for what topic. Are you doing a quantitative or qualitative study, essentially, or mixed methods, potentially? So if you have numbers, if you're looking at numbers and statistics and you're using previously validated instruments, then you're using quantitative approaches most likely. If you need to look at open-ended responses or you need to conduct interviews, then you most likely need to do qualitative. If you're at the beginning of the process, avoid doing mixed methods altogether. Mixed methods just add so much time to the process that I don't feel it's worth it. You'll much more efficiently get through the process if you just pick one. All right, then even before getting into the research questions, first pinpoint the gap in the literature. You have to pinpoint a research problem. Why does the study need to be conducted? What are you contributing that no one else has looked at before? And then you want to pinpoint all the variables of interest in your study. Specify if the variables are numerically measurable. What is the level of measurement? Are they ordinal? Are they nominal? Are they continuous? Are you going to use a self-report survey, or are you planning to use archival data? So something you can do fairly early on, which I have found is very helpful for my clients, is developing a table of all the variables of interest in your study. Okay, so let's draft a couple hypothetical research questions here. So RQ1, let me make this a little bigger. So say that the first question is there a significant difference in transformational leadership in males and females? Say that's our overarching question. So in the methodology, you can develop a table like this. Make it APA format real quick. So what you can do is you'll have a column for your variable name. Then you can put the research question that it corresponds to. Then you can indicate the source, level of measurement, and possible values. So for this question here, we have transformational leadership. This corresponds to RQ1. The source means what is measuring the specific variable. So in this case, you could say the MLQ, which is the multi-factor leadership questionnaire. The level of measurement here would be continuous, and you have to look at the Likert scale ranges. In this case, I think it's 1 to 5 or 1 to 7. I think it's 1 to 5. And then we would have gender. Gender is a second variable. This is also RQ1. This would come from the demographic questionnaire. Would be nominal. And then you can indicate what the specific codes could be. It could be 1 equals male, 2 equals female, 3 equals other, something like that. So you can develop a table for all your variables of interest. If you have multiple research questions, this is especially helpful to give a visual aid to all the moving parts of your study. So I would recommend adding this to your methodology. And now we'll look at some research questions. And the way I've organized it is by research design. These are the most predominant research designs I see used today, especially for dissertations. But first, we'll look at a descriptive exploratory design. This is the most basic design for a dissertation. Sometimes committees will not be on board with this because it's a little too simplistic. But the goal for a descriptive or exploratory design is to identify trends in your sample. We have a couple sample questions here. What are the trends in job satisfaction among teaching faculty? Or what is the predominant leadership style used among managers? If you'll notice here, we're not relating two variables to one another. We're not looking at differences. We're not looking at relationships. We're just trying to describe the trends in the sample. So questions like these are typically addressed with descriptive statistics, using things like frequencies and percentages or means and standard deviations, and even using graphical displays like scatter plots or histograms or bar charts. So yeah, if your committee's on board with the descriptive design, by all means, I would say go with that approach because it is the most efficient way. But most committees will want something a little more rigorous. So next, we'll look at a correlational design, one of the more common approaches I see used. So correlational research is an umbrella concept that encompasses the use of two types of analyses. So if you see a correlational design, usually that means you're either running correlations, which are two-way associations, or you are running regression analyses. Those are more predictive analyses. So we have a sample research question here. Is there a significant relationship or association between X and Y being your variables of interest? When you're doing a correlational design, you don't have to have independent and dependent variables. Or I should say, if you're doing correlational analyses, you don't need to have an independent and dependent variable. You just need two variables of interest. So here we have examples. Is there a significant relationship between age and self-efficacy or education and job position? The type of analysis you run is going to depend on the level of measurement for your variables. So if you have continuous variables that you're looking at, you can run a Pearson correlation. If you're dealing with ordinal data, Likert scale responses or a variable like education level, which is multiple choice, but it goes up a hierarchy, you can do Spearman correlations. And then if you have two categorical factors, like gender or race, or passing and failing an exam, then you can do chi-square tests of independence. This slide, we have the hypotheses written underneath the research question. Very simple to phrase these. You just take your research question and phrase it as a statement. So the null hypothesis is the first one here. We'll see a significant relationship, whereas the alternative, signified with the A here, indicates that we are anticipating that there is a significant relationship. And then the other side of a correlational design is a predictive approach. This is when you usually will jump into regression models. And when you do regressions, you need to have an independent variable and you need to have a dependent variable. The independent variable is often called a predictor, and the dependent variable is called a criterion. So here we have a sample question. Is there a significant predictive relationship between X and Y? Having that predictive relationship language is very important and will signify that we need to run regressions. We have 3 sample questions here. And the approach of what analysis you use is going to depend on how your criterion is measured. So your dependent variable. If your dependent variable is continuous, then you can run a linear regression. If your outcome is binary or dichotomous, then you can run a binary logistic regression. So for example, if you're trying to predict passing or failing of an exam, then you could do a logistic regression, a binary logistic regression. If your outcome has 3 or more possibilities, then you can use a multinomial logistic regression. Not one I see very often, but sometimes. And another rare kind of scenario would be an ordinal logistic regression, and that's used if you're predicting a single Likert scale response, or if you're trying to predict education level, that's when you can do an ordinal logistic regression. Similarly, we have the hypotheses phrased here. There is not a significant predictive relationship. There is a significant predictive relationship. And that's it for correlational designs. All right, next we'll look at experimental, quasi-experimental, causal comparative. These kind of all fall into one family because usually the goal for this is to assess for differences as opposed to relationships. So experimental designs, you're looking at changes between groups or maybe changes over time. All right, so here we have an example research question. Is there a significant difference in the dependent variable Y between the groups of X? So hypothetically, is there a significant difference in job satisfaction between treatment and control groups? That would be an experimental based question. Okay? You can have one dependent variable like this, job satisfaction, but you could also incorporate multiple dependent variables in at once. The number of dependent variables and independent variables that you're looking at is going to make the decision as to what analysis you need to run. So if you are just comparing 2 groups like treatment control, you can do a t-test, an independent sample t-test. If you have 3 or more groups, you can run an ANOVA. So these research questions actually align perfectly to the analysis down here. So treatment control, t-test. You do an ANOVA if you have 3 or more groups. So race tends to have 3 or more categories. You could do an ANOVA here. The third question has multiple dependent variables. So you could do a MANOVA in that case. And then if you're trying to control for additional factors, then you can do an ANCOVA or a MANCOVA. Here are the sample hypotheses, very similar as before. With the second example down here, because we had 3 dependent variables, you could have a separate hypothesis per dependent variable. Okay, so we have one for emotional exhaustion, one for depersonalization, and then one for personal accomplishment. And then with the overlap of experimental design, sometimes you'll see a longitudinal design. And this is usually run if you're comparing for changes over time. Most frequently used in the nursing field. If you have PICO questions and you're getting a DMP, you might, I'm thinking most likely you're doing a longitudinal design because you need to do a pre-test, administer an intervention, and then do a post-test. But you can also add factors like treatment and control. That would be a true experimental design. If you randomly select participants and you assign them to treatment and control randomly, and then you do a pre-test and a post-test, that would be a true experimental design. All right, so example questions here. Is there a significant difference in the dependent variable between time 1 and time 2? So for example, is there a significant difference in knowledge between pre-test and post-test of an educational intervention? The analysis that you run is going to depend on how many time points you're looking at. So for question 1 here, we have pre and post. You could do a paired sample t-test, also called a dependent sample t-test. If you have 3 or more points in time, such as a baseline, then a post-test, and then maybe a follow-up at some point in the future, you can do a repeated measures ANOVA. And then if you're doing a true experimental study where you have change over time and change by group, then you can do a mixed model ANOVA. So this is going to assess for differences over time and by group simultaneously. All right, we have the sample hypotheses here. All right, so in summary, pinpoint your literature first, I would say, is identify a gap in the literature, pinpoint your problem statement and your purpose statement. Then identify if you're going to use quantitative or qualitative, or potentially both. I would strongly recommend only picking one design or one method. Then develop a variable of interest table, like we looked at here, with the variable name, the research question it corresponds to, the source that you gathered the instrument from. Is it continuous? Is it nominal? Or is it an ordinal variable? And then give possible values. Identify if you're going to use a self-report survey. If you are, then look for something that is previously validated, or potentially maybe you're using archival or secondary data. Then in the methodology, you need to pick a research design. Oftentimes quantitative is not enough. You have to be a little more specific. So we looked at these 4 design families today. Then you can develop your research questions hypotheses specific to the design, and then pinpoint what analyses you need to run. Okay, do we have any questions? You can type them into the chat box if you have any questions. And we'll send everyone a copy of the webinar and the PowerPoint. Okay, if we have any questions, can you type them into the chat box, please? You see we have a raised hand here. I don't often use audio in these because, yes, we're going to send everyone a copy. Yeah, I don't tend to use audio on these because we have so many participants that the audio tends to cut out. But yes, we'll send everyone a copy of the PowerPoint and the webinar. Any additional questions? All right, we have a question from Paula. Okay, so Paula's question is, can we use a chi-square for ordinal and nominal? You have a couple options if it's ordinal and nominal. I have seen chi-squares run, so that's 100% an option. But you could also run potentially non-parametric analyses. So your IV could be your nominal variable. Your DV could be your ordinal variable. And in this case, you could run potentially a Mann-Whitney U-test or a Kruskal-Wallis. This will depend on if your nominal variable has two groups. Kruskal-Wallis will happen. The nominal variable has three or more. Okay, so you could either do a chi-square or you could run one of these two options, depending on how many groups are in your IV. Yeah, question from Blanca. Okay, so going through the table right here, would it be possible to go through the table again? So yeah, the table here, do this as soon as you can, as soon as your research questions are set in stone. So you identify, in this example here, we can do another example. Let me pull a research question here. So here is a different research question. Is there a significant relationship between age and self-efficacy? So we have age, we have self-efficacy. Then you pinpoint what research question this corresponds to. I only have one, but you could have multiple questions. So you would just put RQ2, RQ3, and so forth. Then you indicate what is the instrument, the source or the instrument. So age, this could be on a demographic questionnaire. Level of measurement, this could be multiple things. This would depend on if it's fill in the blank or if it's multiple choice. So it's either ordinal or scale or continuous. So it's ordinal, multiple choice, and continuous if fill in the If you get a specific value for age, that would be continuous. If they have to select from a multiple choice response, it would be ordinal. Then self-efficacy, say we're using the GSE, it's the general self-efficacy scale. This would be continuous. And then for possible values, look at the Likert scale on the instrument or look at the scoring instructions for the instrument. 1 to 5 potentially, or maybe 1 to 7, whatever it is. All right. Does that make sense, Blanca? Question from Jacob. Is it okay to have any hypotheses when doing a descriptive design? I've seen it both ways. You can. You can absolutely have hypotheses, but you can't really test them with statistical significance, meaning you're not going to get a p-value. A p-value is going to tell you, do we have a significant relationship or not, or do we have significant differences or not? So usually hypotheses only go with research questions or analyses that are going to have a p-value. So I don't often see hypotheses, but you can and have hypotheses. They need to be general, though. Don't say something like there's going to be a significant difference or significant relationships. It has to be a very general hypothesis. Good questions. Do we have any additional ones? Oh, I see some questions from Jasmine here. Let me move this to the Word document. Study have two designs. It can, but generally the stronger approach is going to overlap. So if I saw exploratory correlational, I would just go with correlational because that is the more robust design. So I wouldn't see both of those mentioned here. But I have seen like correlational and causal comparative. I've seen those types of designs put together. Yep, no problem. Question from Raquel. Can you explain the difference in using a moderator versus a mediator for your model? So mediation versus moderation. Mediation, we have three variables of interest, X, Y, and Z, X, Y, and M, just to make it easy. So this is your independent, dependent, your mediator or moderator. Mediation is saying that the mediator, so M significantly mediates the relationship between X and Y. And then moderation, very similar. All right, so the difference is mediation is saying that M explains the relationship between X and Y. The mediator explains the relationship, whereas a moderator modifies the relationship, modifies or alters the relationship, X and Y. Okay, so one variable is explaining why this relationship exists, and then a moderator is causing the relationship to change. Oftentimes, that's a demographic factor, like gender, age, ethnicity. Those are oftentimes moderators because you might be trying to prove that males score higher than females or something along those lines. Should have said moderation here. Yep, no problem. We have any other questions? Hey, Paula. Yes, you can schedule one-on-one. If you just use the link that Sierra put in the chat box, let me copy and paste that. Okay, I just put that in the chat box for you. I put it in the Q&A box. And then I'll put it in the chat box for everyone here. Okay. All right. Any additional questions about research questions or hypotheses or what analyses to run? All right, very good. Thanks for joining, everyone. Come join us for future webinars and let us know if we can be of any assistance. Have a great day.